Hey, Martin here, and welcome to episode 3 of my advanced modding series. You might expect that this episode is about sounds, however I'm going to change it around with WorldGen. So we're going to do WorldGen today, and next time will be sounds. The reason for that is that for sounds you need to know how the coordinate system of Minecraft works, and you also need that for WorldGen, and I can explain the coordinate system for Minecraft better using WorldGen. So we're going to do WorldGen right now, and let's get started. So our main goal of this episode will be a lesson to how to do WorldGen. We're not going to do a OrGen, we're going to do a original thing. We're going to generate our Dutch flag in the world. So we're going to place down a few Dutch flag blocks to create a big flag, put a pole on it, and occasionally we'll gen it in the world. To do this, we're going to start off with a small example to explain how the block placement and getting how that works. To do that, we are going to make a block spawn as soon as we right click this flag for now. It's just really temporary, but it's something to use to trigger and test our code. So what we can do is we can look at which method we can use in the block class to intercept a right click. So that sounds a bit fake, but if we go to the block class, I prepared a bit. We can do open declaration to go to the superclass, but we can also do F3, and that's a little bit quicker. So there we go. This is the block class, and this class contains all the things we can do with a block. So we can set the hardness, we can get the hardness, we can do a lot. A lot of functions or methods are triggered as soon as things happen in the world. So when you can get the light value of the block when the world needs a light value, and when left click of a block and right click of a block, and there's a lot. And one of the things we are looking for is a right click of the block. And there isn't really a right click function. No, not really. On right click maybe? No, on block clicked, but hits the block. By the way, that's left click this. So we need a right click. There isn't really a name for that, but we can use our handy dandy Control F for this. And if we're going to search through this, we'll find it. Of course, I knew the method name beforehand, though I wanted to show you how I usually go about searching for things I need, which is like this. Oh, there we go. Call upon block activation, or right click on the block. So it's called on block activated. That term is used many times. So this method is being called as soon as a player right clicks a block, and you can see exactly where it's being called by using a call hierarchy. You've got this in Eclipse, also in IDE, and this is a very handy thing if you want to know what each of these parameters do, if you don't know. And when you need to know when exactly this method is being called. So there are 5 methods, or actually 2, because these are overridden. 2 methods where this function is being called, this method. So let's look at this one, for example. And you see that's being called on the player right click. I'm not going to go in depth, and I'm also not going to show you how I got the names of these parameters. I'm just going to give you these because that's not what this tutorial is about. I will do a episode about how to search in the Minecraft code and Forge code to find what you're looking for. But not today. So for now we're going to copy this method and we're going to paste it in here. And you'll see that Eclipse marks it as it does it, overrides the method, the super method, and then we can use this. So this method is this parameter is the world parameter, and a world object. There's a world object for every dimension in the Minecraft universe. So this could be the overworld, this could be the Nether, this could be the end, this could be a Mistcraft age, whatever. And this world has a lot of methods you can call to get information or set information. You can set blocks. This isn't really the best. Let's see, set block. That's this one, and you can get a block. So if we look at get, so that will get a block at a certain XYZ chord. And you can do a lot, a real lot. You can get a light value at a certain XYZ, or yeah. So we're going to use this, of course, to set a block. So this is the world. This is the X, Y, and Z. So if you know how to use F3, you probably have seen this and you know how this works. So X and Z are the horizontal coordinates, and Y is the vertical axis. And we'll look at this in a second as well. Entity player is the player who right-clicked the block. This integer is a side of the block that's being clicked. So if you right-click the bottom side of the block, it will be a 0. If you click the top side, it will be a 1. And so on and so forth. These floats are a hit factor, and I will not go in depth what this is, but it can be used to determine which part of the block the player clicked on. So next thing I'm going to do, I haven't really changed anything because the super method looks exactly the same as this one. Just other names, but that doesn't really matter at runtime. So let's just load up Minecraft, and what I've done is I've loaded it in debug mode. And what that will allow you to do is it will allow you to change code while Minecraft is running. And this is really handy because any change you do, you don't have to restart Minecraft to apply these changes. So this is our Dutch flag. It's still the same as it was last time. Also take a note that when I right click a flag with a flag, it will place down a flag. And that's what this boolean is for. If you return true, that won't happen anymore. See, unless I press shift, then it will allow you. And this method isn't being called on the server side. It is when pressing shift. But I'll not go in depth how the server and client are laid out. That's for another episode as well. So this boolean is being used in, for example, the furnace to not place down a block when you right click a furnace, but instead it will open a GUI. And we're going to leave that true as well. We are going to do something in this method. So we're going to set a block, and let's just, for example, place down a flag on top of a flag when you right click a flag. Lots of flags. So you can do this by, we're going to do that set block in the world. So we're going to do world dot and do something with that world. Set block, that's a nice one. There are two types. I'll go over them both, but for now we're going to do the shortest, which is this one, and it requires a X, a Y, a Z, and a block. So XYZ, that's just these XYZ, but this will mean that we are placing a block at the location of a flag, we right click. We want to go one above that flag, so we need to do a y plus 1, because if you look at F3 and you go up, the y increases. So this is basically the same. And that's good. Now for the block we're going to set. You might think that you need to do, so for example you want to place down redstone, you could do new block, or block, let's do block stone. Input block stone and done. This is very wrong, very wrong, because every block only has one instance. So you shouldn't create a new block. Every block gets instantiated in the initialization. If we look at our own mod blocks class, you'll see that we're creating a new instance right there. So if you want to place down a block, you need to reference existing created blocks. So you need to reference this variable instead. Or you need to look, if you want to place down Minecraft blocks, you're going to look at blocks. Note the difference between block. So block is a class which contains all properties of a block, and blocks contains all the blocks of Minecraft. So if you want to place down Minecraft blocks, this is the class you need to look for. So this contains all the Minecraft blocks. So if you want to place down TNT, TNT, there you go. So you could do blocks.tnt. And this is the right way to do it. So not new block TNT. That's wrong. That's I have to remove that right away. That's just too wrong. And it won't work. You will crash, or I'm not exactly sure what happens, but rest assured it will not work. So we're going to place down a flag. So as we've seen, our flag instance is right here in modblocks.touchFlag. So we can do modblocks.touchFlag. And that's all there's to it. We can save, and as soon as I save, this change will be sent to this Minecraft instance. Let's just call it like that. So this method should have been changed here. So if we right click, boom, it put on a block. And if we right click that, and actually if we right click this block will be replaced, but we don't see that. So you can see this as a kind of relative coordinate. If we take a certain coordinate and add one to it and place it down one above it. We can do this for the x plus 1 as well. There we go, x plus 1, apparently. We can also do this, x plus 1. We can do x plus 10. So if we right click this, boom. Whatever you want. And this will also replace dirt. So let's try something. Let's try both. So we're going to place it 10 blocks over there and then 1 into the ground. So you can do y minus 1. There we go. So it replaced the grass without knowing if it could. Well, we determine if it can replace it. But you can do absolute coordinates as well. Let's say you want to place down a block at right here. So we can do 7914153. 791 4. This is just to show, just to give you an idea of how it works. And let's see if it works. There we go. That's where we stood. There isn't really often where you actually want to use absolute coordinates I can't think of any really, but this was just to show how it works. So we could create structures if you do for and y equals 0, y is less than 10, y plus plus. And maybe we can start off at 4 and place 10 blocks to make a row of 10 blocks. So we could do 4 plus y. And now if we right click it, boom, it creates 10 blocks. Now let's see if we can make it so that it only will replace blocks when it is allowed to. So let's remove this and make this relative coordinate again, x, y, z, and do x plus 1. So this will place down a block as one above the flag. But let's say we don't want to have it whenever there's another block on top of it, that we can replace this block. So we can do that by checking which block is there, and if it's not replaceable, if it's, for instance, air. When it's not air, we'll just leave it as B. So we can do if world get block at the x, y plus 1, z. At the block, we are checking the block above, and if that block equals blocks.air, there's a block called air, then we allow the block placing. So we could do this, but if we place down a furnace, it won't do anything at all. This isn't really the best thing to do it, to check for air, because you might know of a very famous bug in the modding community, the Railcraft the heat source block. Forge allows you to make custom air blocks. So we're hard coding to check for a blocks.air from Minecraft, the air block. However, there might be a block from a mod somewhere floating around above this block, which acts exactly like air and can be replaced. However, it won't allow block placement if we check for just the Minecraft air, because it's not the same block. So there is a built-in method in that Forge added, which is world.isAirBlock. We can use, and we can look at what this does, but yeah, it will allow for other mods to override this and return true if it's a air block. But well, it's cool to look at, but not necessary for us. So now it will work as well. It will replace it. So the same result, but let me show you. You need this instead of equals blocks there. Instead of this, that. Note with the hotcode replacement feature, so the one that allows you to change code on the fly, that it won't work whenever you create methods. So if I do private void blah and I do contrast, it will yell that it won't work. So keep that in mind. But for the most part, it's an awesome feature, and I can't really miss it. So we've looked at getting of a block and we've looked at setting a block. Let's now look at how we can use this in a world generator. So when the Minecraft world generates the world, it will place down our blocks. So to do this, we need to hook into a FML feature, and it's called IWorldGenerator, and we need to create a class that implements this and register that to the game registry. Might sound a little bit fake, but let's do it. So we need to create a new class. There we go. Oh, whoops. Let's go from here. And let's create a new package, and I'm going to call the package. I like to call my packages the same as Minecraft does. So it has its WorldGen right in there, and world.gen. Actually, it would be a feature, but let's do world.gen. Or just WorldGen. I think. No, world.gen. World.gen. And we're going to call it WorldGenerator flag. And something nice in Eclipse, you could just press OK. Let's do that and do implement blah blah blah. Implements IWorldGenerator. Another thing you can do is, if we delete this again, new class, WorldGenerator flag in world.gen. You could also put in a super class, so that's just the default for now. But we can also add an interface, so we can do IWorldGenerator, that's the one we want, and do enter or finish, and we'll automatically do that. You could also, it only saves a few seconds, but that's quite nice. I like to use it. So this is the method that's being called every time a new chunk generates. So let's go into Minecraft for those of you who don't know. So there you go. And if we look at R3, you can see that there's a value for X, Y, Z at the middle left, and after that there's a C number, and that C number displays a chunk. So for a Minecraft world is divided into chunks of 16 by 16. So you can see that happen from 15.0. There we go. So from here to, I'm looking at the number behind the C now to see where in the chunk I am. That's not really true. Let's see. 15, boom. There we go. So this is one chunk. A area of 16 by 16, and basically the Minecraft world is a grid of those chunks, and you can see those. The rendering also is divided in chunks, and world generation also is divided in chunks. So per chunk that's being generated, this method will be called. So we're going to use that right now. So what you see, the things that are given are a random, and that random you really need to use that random because it has the seed in it, the world seed. So the seed that determines how the world is going to look, you can also use that to generate your own features. So that way if someone puts in a feature, a seed with your mod in, it will always generate flags at the same location. So it's pseudo random, but that's what you want. You could also do a new caps is on. New random get integer or next int, but that wouldn't be dependent on the seed then anymore. Chunk X and chunk Z, those were the numbers that you saw in F3, so the C numbers. So those are the chunks you get, the chunk you get. The world, so that's again overworld, the nether, the end. We need to keep that in mind, and these I won't go into. We don't need that for now. So we're going to, let's just start off with a simple thing to test if this works. So we're going to place a block at Y level 30, so that's midair for a flat world. And let's place it at the first block of every chunk. So we could do a world.set block chunk X chunk y level 30 and chunk Z, and the block we want is our flag, so that's mod blocks Dutch flag. If you see something wrong here, then you're correct, and we'll see in a second what's wrong here for those of you who didn't see it. Let's go into our main class, because we've created this class but we didn't do anything, so FML doesn't know that we want this IWorldGenerator to be working. So to do this, we can go in the pre-init and do a game registry, register world generator, and that's the generator we've created. So we can do a new world generator flag. This is a number that was added in 1.7, Minecraft 1.7, and that's basically a number that states which priority this world generator has. So for now I'm going to do 0, which is pretty neutral. But if you do low values, the lower the value, the higher priority. So if you need to, if you have something that needs to be generated very first, then in front of all other mod generators, then you need to fill in negative numbers, a low negative number, and if you want to generate after all world generators, you can do a high value. But for now it doesn't matter, so I'm going to do a neutral value, which is 0. So now FML doesn't know that we want to generate, and let's start Minecraft. So Minecraft is loaded, let's dive in. Remove the old world with our flags, create a new one, and start it up. So there we are, but I would have expected that we have gotten a block for every 16 blocks in every direction, so a grid of flags. That is not the case. So what's the problem? If we look at this, we can head off over there, but we can also do TP armor called player 301. TP player 301 0 20 0. And what's happening here? So we can see some blocks here, and they are very close together. So, blocks are being added as soon as the chunks are being added. Oh, I know what's happening here. These parameters give you the chunk, so it gives you the C value, the C0 and C1, C-1 there. So we still need to scale that to actual block locations, and unfortunately it isn't that bad, it's just a matter of times 16. So if we do that, that's scaled it. Let's create a new world, because this is a bit bored. And let's see if that works better. Oh, not really. So that worked. Cool. A grid of flag blocks. How awesome is that? For every chunk 1 in the far corner of the chunk. So you might have noticed that I needed to change something there. I'll explain that in a second, or we could do that right now actually. So what happens if we don't have this? We will crash, and we will see why if we create a new world. How hard is it? Can it be? There we go. So crash, and why does that happen? So when you don't add anything in here, it will default to a certain way of placing a block, and that is, it will place the block and it will cause a neighbor update. So you all know the block update detectors. That's what they're detecting. They're detecting a block that's been placed or changed, and yeah. So the problem with that is, as soon as you place down a block, it will search for every block around it, next to it, neighboring it, and then it will invoke that on neighbor block update. Cool. But it is a problem if you have got a block being generated at the corner of a chunk, because if I revert to the working code, we've got this, and it's in the corner of the chunk, and as soon as you place it down, it looks at all neighboring blocks, so it gets a block, and it then will do a neighbor block update. But as soon as it got the block, if it detects that the chunk isn't generated yet, it will generate a chunk first before it will look if it needs to do a neighbor block update. And this will go on and go on and go on and go on to infinity, or till the stack overflows, which is what happens here. So it's important to do that. I could also have fixed it by not placing a block right in the corner, but a little bit offset. That would work as well if we look at that. That would have worked as well. So what do these parameters mean I've put in? 0 is the metadata. I think I'll do that in another episode. And this 2, that's actually what determines which... 0, 2. This 2 actually determines what happens to the block after it's been placed. So, and also says in this Java docket right here. So 1 will cause a block update, 2 will send a change to the clients. We'll go over that later, but you always want to do that. And that prevents re-rendering. So when you don't, we could look at the call here key. There should be a set block. There you go. When you don't specify anything, so you use the simplified version we used over here, it will do a flag of 3, meaning it will cause a block update, flag 1, and 2, it will send change to the client. So this is a binary flag. So you can add them all together if you want to prevent them from being re-rendered. You want to send the changes to the client, and you want to cause a block update. You can add them together. So you do 1, 2 is 3, plus 4 equals 7. So you do 7 for the flag. Or 3 for a block update and a change to the clients. And what we did is 2. So we send a change to the clients. We'll go over what that means later in another episode. But we don't cause a block update by doing this. And that's what this fixes. If you don't cause a block update, that's also better for performance. And especially in world generating, you want to have that. So if it's not necessary to cause a block update, don't. It will save a lot of generation time. And you can see that Minecraft also uses this because of all the caves generating under deserts, and then when you cause a block update, the entire cave falls, it collapses. That's because it didn't cause a block update when it was generated. This concludes part 1 of the world interaction and generation tutorial. Stay tuned for part 2.